If we want to do chemical reactions in water, that means that we are going to form a mixture. We are going to dissolve a substance into water so that the chemical reaction can happen. So if you think about things you have experience with, like salt or sugar, when you dissolve that into water, it seems to disappear or become a liquid. When it dissolves, it becomes a homogeneous mixture, a mixture that is evenly distributed throughout. We know that the salt or sugar is still there because we can taste it, and we can get that salt or sugar back by boiling away the water, and the solid will be left behind. So these homogeneous mixtures are what we call solutions. Solutions are made up of two components. The first component is the state that changes, this substance that changes state is called the solute, usually present in a smaller amount. And the component that keeps its state is called the solvent. So typically, particularly in this chapter, it is going to be water. If both components start in the same state, then the major, or the one that's present in the larger quantity, is the solvent. When we're talking about solution concentrations, we can talk about them qualitatively by describing them either as dilute or concentrated. So dilute means that there is a small amount of solute dissolved in the solvent. Or if it's concentrated, that means that there's a large amount of solute dissolved into the solvent. And so you can think about this like strong or weak coffee. If it's strong coffee, it has a lot of those flavoring components that are dissolved into the water. If it's weak coffee, there's only a small amount of those flavoring components dissolved. Dilute and concentrated are good qualitative ways to describe our solution, but we're going to need a way to identify how much of the solute is in our solution. And so we are going to report this as a concentration known as molarity. And molarity is moles of solute in 1 liter of solution. So it's moles over liters. And this helps us describe how many molecules are in the solution. This is a really important concept because although we report it as a capital M, and you'll see the concentrations as 1 molar, 6 molar, it's important to remember that there's hidden units, that it really means moles divided by liters. This will make the math that we're going to do much easier if you can remember that molarity is moles over liters. So when we're preparing a solution, say we want to make a 1 molar solution of sodium chloride, we're going to have to add 1 mole of sodium chloride, and the piece of glassware that we use is called a volumetric flask. So a volumetric flask measures out 1 volume very, very accurately. We add 1 mole of sodium chloride in, and the way that we add that in is using our molar mass to weigh out 1 mole of sodium chloride. So we weigh out 58.44 grams. It's good to start with a little water in the volumetric flask before you add your solid. Swirl it to dissolve it into the solution before adding the water up to the measurement line on the neck. Once you've added the solution up to the measurement line, you do want to make sure that you mix it again so that your entire solution is a 1 molar solution. So molarity is the quantity. When we refer to it in conversation, we would say a 1 molar solution. So let's try an example. Let's find the molarity of a solution that has 25 grams of potassium bromide dissolved in 1.5 liters of solution. So we're going to start with our 25.5 grams potassium bromide, and because we're trying to find the molarity, remember molarity is moles over liters, we have to find the moles. So to find moles, we're going to have to take the mass of potassium plus the mass of bromide, use the molar mass, which is 119 grams for 1 mole potassium bromide. And we can find that we've got 0.21429 moles of KBr, potassium bromide. So to find our molarity, our volume is already given in liters, so we don't have to do any additional conversions. We're going to take our moles, divide by the liters of solution to get our molarity. So 0.122 molar potassium bromide solution. Here's a practice for you. See if you can find the molarity of our ammonia solution. Pause the video and determine the molarity. So technically, ammonia is a gas. When we dissolve it into solution, it becomes ammonium hydroxide. So if you see ammonia or ammonium hydroxide, those get used interchangeably in chemistry, but technically it's NH4OH when it's dissolved in water. So back to our problem. 3.4 grams of NH3, and our molar mass is given 17.03 grams in 1 mole. This results in 0.20 moles. We have to convert, we've got 200 milliliters of solution, so because it's milliliters, we have to convert to liters. It's 1,000 milliliters in 1 liter. And now we can find our molarity. Moles divided by liters, 0.2 moles divided by 0.2 liters. So we end up with a 1 molar ammonium solution. So to make this, we would add 3.4 grams of ammonia, fill our volumetric flask up to 200 milliliters, and make sure that it is mixed thoroughly. Now, because molarity relates moles to liters, we can use this in our calculations as a conversion factor. So molarity, it shows that relationship between moles of solute and liters of solution. So if we say that sugar has a concentration of 2 molar, then that means that for every 1 liter solution, we have 2 moles of sugar. If we have 2 liters, we have 4 moles. If we have half a liter, we have 1 mole. And so there is a relationship here. And because there's a relationship, we can use it as a conversion factor in our dimensional analysis to go from moles of solute into volume of solution. And this is very helpful because it helps us to let's look at how this is helpful. Let's determine how many liters of a 0.125 molar sodium hydroxide solution contain 0.255 moles of sodium hydroxide. Now we have two numbers here, but what I notice is this is a molar solution, so it actually has two hidden units. So that's going to go a little further down the problem. We're going to start with the number that we only have, that only has one unit. So our 0.255 moles of sodium hydroxide. Now we can use our molarity, which has hidden units of moles over liters. We want our moles to cancel, so the number goes with the moles. And our moles will cancel, leaving us with liters of solution. So it would take us 2.04 liters of sodium hydroxide solution to deliver 0.255 moles. Now sometimes you'll see solution abbreviated SOLN, just so that you're aware that that is equivalent to solution. Here's a practice for you. Determine the mass of calcium chloride, molar mass is provided, in 1.75 liters of a 1.5 molar solution. Pause the video and determine the mass. So again, our molarity has units that relate moles to liters. Our molar mass has units that relate grams to moles. So I want to start with the number with just a single unit, which would be liters per volume. Now we want liters to cancel, so our 1 liter of solution goes on the bottom. 1.5 moles of calcium chloride go on top. Liters cancel. Now if we want to find grams, we need our molar mass. We want the moles to cancel, so 1 mole goes on the bottom. 110.98 grams on top. Multiply across the top, divide by anything on the bottom, and so it would take 291 grams of calcium chloride to make our 1.75 liter solution of 1.5 molar concentration.